Okay, we're talking about square numbers today. Our objective is to introduce square numbers and the exponent key on a calculator. Which of these numbers can be made into an array with the same number of rows and columns? Our choices are 14, 16, or 18. So take a second. What do you think? Well, you can think about the factor pairs that go into each. So 14 is 1 and 14, or 2 and 7, 14 and 1, or 7 and 2. But I'm not going to get equal rows or columns. For 16, I have 1 and 16. I have 2 and 8. I have 4 and 4. Well, 4 and 4 are equal number of rows and columns. Let's just check 18 to be on the safe side. 18, I have 1 and 18, 2 and 9, 3 and 6, 9 and 2, 6 and 3, 18 and 1. So 18 is not going to be a good choice. So 16 is our number that can be made into equal rows and equal columns. So what does that look like? 2, 3, 4, 1, 2, 3, and 4. You can make an array like that, with equal rows and equal columns. And you can even draw a handy-dandy rectangle, or otherwise known as a square, around the shape. So when you can draw a square around an array that has equal rows and equal columns, we call it a square array. So a square array is an array that has the same number of rows and columns. I keep forgetting to hit my pen. All right. Has the same number of rows and columns. That's the key, that's the ticket right there, is that you want to make sure you're aware of that. Square array, same number, rows and columns. Okay. On that 16 square, it was 4 rows and 4 columns, and you could draw a nice little circle, a square around it. Okay. So, the number 16, since it is a square array, is also called a square number. So a square number is the number a square array represents. So a 4 by 4 array shows me the number 16, which is a square number. Okay, so the next question. Can we draw square arrays for 1, 2, 3, and 4? Well, let's start with the number 1. What is an array for the number 1? Well, 1 would just be this, right? 1 row and 1 column. Okay, just a dot, basically. Can I draw a square around it? Yeah. Okay, so technically it is a square array even though it's only 1 dot. Okay, what about the number 2? Can I do a square array around the number 2? Well, I've got 2 dots, and I'm not going to get a square. Okay, so 2 is not a square array. Definitely get a rectangle. Okay, that is not a square. 3, well, I've got 3 dots, 1, 2, and 3. I could, whether I did it going horizontally, which is left to right, or vertically, which is going up and down, it doesn't matter. I still get the same kind of rectangle. Okay. What about 4? Well, you can do 1 row of 4, so it's a long rectangle, or you can do 4 rows and 1 column of 4 going up and down. But I can also do this. I can do 1, 2, 1, 2. So yes, I get a square array for the number 4. So that's 4, this is 3, this is 2, and this is 1. So I get a square array for the number 1, and I get a square array for the number 4. Can you guess then what the third square number is? So if you think we've already done 1, 2, 3, and 4, is it going to be 5, 6, 7, 8, or 9? Remember, it has to have equal rows and equal columns. So if you think about what numbers can be turned into squares, the next one is going to have 9 dots, because you can get a row 3 by 3. So notice this is a 1 by 1 array. Here is a 2 by 2 array. So this is a 3 by 3 array. So I go from 1 to 4, and I end up with 9. All right, so take a second and write all this down so you get the image of what a square array looks like going from 1 to 2 to 3 to 4 to 9, okay? And realize that, let me change my color really quick. Realize that the square arrays are that one, and that one, not the other two. So what is my big idea? Arrays that have Mr. Shanto, arrays that have equal rows and equal columns are called square arrays. So a square number is the product of multiplying two factors that are the same. So we are multiplying two factors that are the same, or equal. So in the case of 1, it was 1 times 1. In the case of 4, it was 2 times 2. And in the case of 9, it was 3 times 3. So how do we write square numbers? So the third square number is 9 and is written 3 times 3. Okay, we've already demonstrated that. So it can be written this way. 9 equals 3 times 3, or 3 with that little 2 equals 3 times 3, or 9 equals 3 with that little 2. You read that 3 with that little 2 as 3 times 3, or 3 squared, or 3 to the power of 2. The raised 2 is called an exponent. Again, another word that you need to write down. We'll write all of this down. It means that 3 is used as a factor 2 times. Now, that exponent number can change. It can be any number, for the most part. Okay. For our purposes, most of them are going to be positive numbers. We might run into negative exponents at some point. But for right now, understand that when you see that 2 above, or next to the 3, and it's a little bit above, it could be a 3 to the power of 2, it could be 3 to the power of 10, it could be 3 to the power of 16, 3 to the power of 3. That means you're multiplying 3 times and that number of times. So again, I'm multiplying 3 times 3. Now, if it was 3 to the power of 3, that would be 3 times 3 times 3. But right now, it's 3 to the power of 2, which is 3 times 3. Or 3 squared, or 3 to the power of 2. So an exponent indicates how many times a number is multiplied by itself. Okay, so it's how many. This is very important. How many times a number is multiplied by itself. Those are the very most important parts. And we call numbers written with exponents exponential notation. So this is standard notation. Okay, 9 equals 3 times 3. That's standard notation. But this, since there is that exponent right there, 9 equals 3 squared, it's called exponential notation. So numbers written with exponents. Oh, Mr. Shanto forgot a period after exponents. There we go. Now he's got it. Okay. So 3 to the power of 2. 3 is called the base number. Oh, I'm sorry. Let me back up a second. In 3 to the power of 2, 3 is called the base number, and 2 is the exponent. Okay. Everyday math really doesn't at this point refer to base number, but that's something that you'll need to know when you move it, particularly when you move into 6th grade, that the base number, you'll start labeling the base number. Okay. For right now, we're just calling that 2 an exponent. Danger, Will Robinson, danger. So my friend Robbie the robot is here to help me tell you that there's something that you need to be aware of. Be careful. Be very careful. 3 to the power of 2 does not mean 3 times 2. This is a very, very common mistake. It's not 3 times 2, okay? It's 3 times 2 equals 6, and 3 to the power of 2 equals 3 times 3, which is 9, okay? This doesn't mean 3 times 2. So get that out of your head. It's that, and this is where you're going to make a, well, let me back up a second. This is where students often make mistakes, and so be very, very careful when you see this and when you notate it, when you write it in your own work, that you don't confuse yourself, that you're thinking you're multiplying 3 times 2 rather than you're multiplying 2 3s. Okay, exponential notation versus standard notation versus square number. We have 4 times 4. So my exponential notation for 4 times 4 is going to be 4 to the power of 2, 4 squared. What number is 4 squared? What square number is 16? My standard notation is 7 times 7. So my exponential notation is 7 squared, which means 7 times 7. So my square number, what's 7 times 7? 49. 10 times 10? 10 to the power of 2. Okay. What's my square number? 10 times 10 is 100. Okay. Next is 11. So if we're talking about square numbers here, okay? So if I just have 11, I'm multiplying by 11. What's my exponential notation? 11 squared. Okay. What is my square number? Well, I know 10 times 10 is 100. I've memorized 12 times 12 is 144, so I'm looking for something right in the middle. So I do know that 11 squared is 121. Okay. All right, so that's it for this lesson. Rewatch the video if you've missed anything or want to go back and double check your work. Make sure you have your notebook with all of the notes, including this table, written in it, and don't forget to take the quiz on Edmodo. And I'll see you in class.